Good afternoon. I am Mr. Chen, and this is 8th grade math. In this unit, we will cover exponential notation. Exponential notation traditionally is written in such form. The first activity I want you to do is to copy down this notation on your notebook, and on my signal, pause the video and spend about 3 to 5 minutes thinking about this, or look at it and come up with questions. One question may be, how come the C is written as a superscript? So those are the things I want you to ask yourself, and then at the end of the unit, we will come back and reflect upon the questions and see if you answer them yourself. Welcome back. So this is called the exponential notation, and let me just give you some terminology. For A, this leading A, we call it the coefficient. That's the coefficient. For B, it's the base. And as you may guess, C is called the index or the exponent. And there you go. These are the terminology of exponential notation. We read this out as A times B to the power of C, or A times B raised to the power of C. This, assuming that C is a positive integer, what this does is, this is equal to A times B times B times B multiplied by B multiplied by itself, C number of times. C number, the amount of B's. And that's it. This is assuming that C is a positive integer. And now that we have this down, let me go into some of the rules we have for exponential notation. The first rule we have is, let's just write it out. And so we have base and index up here. We're going to use an example. So we're going to say 6 raised to the power of 3. Let me write out what's called the expanded form. So you can see that the expanded form of 6 to the third is just 3 6 multiplied by each other. Now we move on to what's called the product rule. So here we have two exponential notations multiplied by each other. And to write it out in expanded form, this will be, the first term is 6 to the third. The second term is 6 squared. And in total, we can count 1, 2, 3, 4, 5. So we have 5, 6, 6's multiplied by each other. And so we write this as 6 to the 5. Now, if you pay some close attention, you will realize that at the end, 6 to the 5 is just the addition of the exponents. So 6 to the third multiplied by 6 squared is 6 to the fifth. Next, division rule. So division rule is shown as such. If I have 6 to the fifth divided by 6 to the second, we write it out. 6 to the fifth is just 5 6's multiplied by each other. And 6 squared is 2 6 or 2 6's. Now, previously you may have learned that if you have something in the numerator and the denominator that are the same, you can cancel them out. So let's do that. So I'm left with 3 6's, and that's 6 to the third. Then we have power rule. Power rule is just so if I have 6 to the second raised to the third, what this does is I raise what's in the parentheses to the third, and so it multiplies by itself 3 times. Let me write it out. At this point, you can tell there are 6 6's multiplied by each other, and so you write it in the form 6 to the 6th. And so 6 to the 6th is just a result of these two numbers multiplied by each other. And the next thing we'll talk about is negative exponent. You may be wondering, for now, all the exponents are positive, and so now we talk about negative exponents. So negative exponents So we have a negative exponent. 6 to the negative third is 1 over 6 to the third. And one more thing. So we talked about positive exponent, and we talked about negative exponent. One more thing is what happens if something is raised to the 0 power. And so this is by definition anything. I'm going to write anything raised to the 0 power, it's just by definition 1. So these are the few rules that we covered. So this is how you write it on standard exponential notation. This is the expanded form, the product rule, division rule, the power rule, and how we treat negative exponents. And over there we have the 0 power. So now that we have the calculation or the basic definition down, let me go over some of the daily usage or where you may have seen this in action. Places you may have seen exponential notation in play are, for example, the area of a circle, that is, area of a circle is A equals pi r squared. So in this case, the coefficient is pi, the base is r, and the exponent is 2. So pi r squared, if you write this in its expanded form, this is just going to equal to A equals pi times r times r. Another example of exponential notation would be the volume of a sphere. So volume of sphere equals to V is V equals 4/3 pi r cubed. In this case, the coefficient is 4/3 pi, and the base is r. The exponent is 3 or cubed. One other example would be the speed of light, how we write it. So the speed of light is written in this way. So 3 times 10 to the 8th meters per second. Just to avoid me writing all the zeros, we write 3. So the coefficient will be 3, the base will be 10, and the exponent will be 8, meaning that there are 8 zeros trailing the 3. Or you can write it in standard form, that would be 300, 0, 0, 0, and then like such. So it's basically 300 million meters per second. Now that the instruction part of exponential notation is complete, I will kindly ask you to go back to the page where you had the initial question about the form, about the exponential notation that we copied. Let's see if we answer those questions. So back to the original question. A question may be, what does A, B, and C stand for? Now, these are just variables, and so you can easily replace it with any variable of your choice. But we know that A is the coefficient, B is the base, and C is the exponent. We know that when A, B, and C are all positive, this is just A multiplied by B, and B multiplied by itself C number of times. So it will just be B, B, C number of times. C number of times. And so some other question would be, where have we seen this before? And we have answered that question in the previous board about the formula for the area of the circle, the volume of the sphere, and some other ways of writing the speed of light. So having exponential notation at your hand will just shorten the number of calculations, or it won't shorten the calculation, but it will shorten the way you write it. This ties into the next topic we will cover, which is scientific notation. Now, thank you. Good night.